This is EGME-331 Solid Mechanics Prerequisite video series. In this video, we'll be reviewing the topic Material Deformation. So in engineering terms, materials deform or flow when a force is applied. That means when a sufficient load is applied to a material structure, it will cause the material to change shape. And this change in shape is termed as material deformation. Now the amount of material deformation is known as the strain, and how fast the deformation occurs is known as the rate of strain. Also, the applied force per unit area is termed as the stress. We have two kinds of deformation, the elastic deformation and plastic deformation. A temporary shape change, that is self-reversing after the force is removed so that the object returns to its original shape. This is termed as the elastic deformation. In other words, elastic deformation is a change in the shape of the material at low stress that is recoverable after the stress is removed. This type of deformation involves stretching of the bonds, but the atoms itself do not slip past each other. On the other hand, plastic deformation occurs when the stress is sufficient to permanently deform the material. That means plastic deformation is a permanent distortion that occurs when the material itself is subject to tensile, compressive, bending, or torsion stresses that exceed its yield strength and cause it to elongate, compress, buckle, bend, or twist. Let's take a look at some of the examples of deformations. We have several types of deformations. We have the homogeneous deformations, which are of high interest. This includes the uniform extension. We have the plane strain, pure dilation. We have equibiaxial tension, the simple shear, pure shear, and so on. So there are various forms of deformation, and each deformation is analyzed differently.